How are you guys doing today? Good.
How are you?
I'm fine, thank you. How was your weekend? Did you enjoy your past week of the semester?
I wasn't here.
Did you miss the entire week?
Yeah.
Oh wow, what happened? Are you okay?
Yeah, I'm fine.
So you missed a lot of materials, but no problem. You have our recording.
2 lectures that I missed.
One lecture you missed for us. But if you have twisted faster classes, you missed 3 lectures. So if you miss anything, here the recording, you can access them through our Brightspace or simply subscribe. So we have, when you go to our Brightspace, under content, on the left side it has class recording, and just click on the playlist, and then our class is 06, section 6, but I taught the same thing. So you can just click any one of them, and then whatever you missed, you can
So
find
it's the same lecture for 2 different.
Yeah. I wish I could combine my 2 classes into one.
Yeah.
I don't have to tell the same thing twice. It's kind of boring. But one good thing about is that whatever mistake I make in my first class, I can fix them in my second class. It is good. Okay, about homework. To access the homework or to submit the homework, you can simply click on the homework tab on the top or on the left panel. It doesn't matter where you click. You'll see this. I said from this page, just do these questions and submit in one PDF file, if possible.
Wait, just before.
Not going code.
Oh, yeah, I mean, fine. That's like,
1D, question 2.
I was saying, I was just, okay. Wasn't gonna ask how to do E. We don't know how to do E. We can't use back substitution with E, with 1 E.
We need to do a few back substitution today. So if you know, you can also do that. Also, to make this bigger, to see it clearly, you can right click on the mouse and then open new tab and then zoom in. You can see it bigger. And to submit, all you have to do is click on the homework and then upload your file from wherever you have.
Today, right?
It's due tonight midnight, but for this homework only, if you can't finish it tonight, you can do it by next week. I have few students swapping classes. So for them, I'm giving all of you a chance. If you didn't complete by tonight, no problem. You have until, let me see what it says. Available until some date. Monday or Wednesday, I forgot. Available until September 3.
It's gonna be only for this one.
Only for this summer. That's my plan.
Available till the 8th.
Available till 8. Oh yeah, 8.
Yeah.
Today's, yeah. So it's do it tonight, but if you can't, it's okay. It will be available until 8. So definitely upload before 8.
Thank you. Is there any points off for this first time uploading it on the 8th?
For the first one, no problem.
Thank you.
You get full points. My plan is to publish the solution after every due date. So if it's due tonight midnight, I supposed to submit the solution after 12. But since for the first exam, for the first homework, I'm giving you time. So I'm going to publish the solution after 8. So that's why I want you to complete everything by the due date so that once solution is up, you cannot submit anymore.
Are you doing weekly homework? So
Yeah.
like
Every Monday. And since we don't have class Monday, so their due date is Wednesday. But from next 2 weeks, all the homework will be Mondays.
So varies. We don't have another.
Hmm?
We don't have a class next Monday.
Yeah, I have conference to go to, so only for us, we're not going to have a class next Monday. We're going to have a class Wednesday.
Is that on the right space? So I know.
I didn't say that yet, but I'm going to make an announcement over the weekend. Any other question before we start? Comments, concern, complaint? No phone class started now. Okay, so our last class we talked about, I already forgot we talked about what? System. So we said we have system of equations and we can convert system of equations into augmented matrix. So we don't have to write a bunch of equations. We can simply look at the coefficients and the constants and then work with them. So we want to solve system of equations. To solve them, we want to reduce our augmented matrix. When we reduce our augmented matrix, we can solve for the variable individually. And to reduce, how are you going to reduce? That's the main purpose behind this class. So first, we start with the definition. In an augmented matrix, do you remember what is an augmented matrix? What do you have in the augmented matrix? Coefficients on the left and constant on the right. So the very last column is the constant, and everything else before the last column is coefficients. So
put a system of equations into augmented, you have to put the
coefficients
coefficient on the left
and then constant on the right. And some people use a bar, like here, use a bar to provide the constant and the coefficients. And some people, they don't use anything. We just have to visualize that. We just have to assume that the line is there, the vertical line. But anyway, so in that augmented matrix, there is a number, we call it pivot, or pivot entry, or leading entry. And that entry is very important. Why? Because by looking at pivot, we can see what we have to do next. So the pivot is the very fast non-zero entry in any row after the matrix has been reduced to row echelon form. The specific location of this non-zero entry is called the pivot position. The pivot is an element on the left-hand side of the matrix that you want the number above and below to be zero. For example, here, in this matrix, row-wise, we have 4, 1, 0. So our 4 is a pivot entry. It's a fast non-zero number. Second row, we have 0, it doesn't count. So we go to 2, 2 is a pivot entry. On the third column, we have 0, 0, they don't count. Negative 3 is a pivot entry. So all of these are pivot entry in this matrix. And in every column, you have only one pivot entry, or in every row, you have only one pivot entry. You cannot have more than one pivot in one row or in one column. So how we select the pivot? First, it has to be non-zero. And it can happen only once. If possible, if you have a 1 as the first entry, then make that as a pivot. Or if you don't have 1, make it 1 to make it pivot. Make the pivot on the main diagonal. Means when you look at the diagonal, you know what is diagonal, right? So when you look at the diagonal of the matrix, you want your pivot entries to be on that diagonal. 0 can never be pivot. 0. And we can never have the constant to pivot. Pivot can only be the coefficient. The constant can never be pivot. So these are some of the criteria to follow when you select a pivot to reduce. And here, this one says, well, pivot is the number when you have the between row echelon form. So what is row echelon form? A matrix is in a row echelon form if it follows or if it satisfies these three conditions. These are written in formal language, and these are written in informal language. I like the informal one, so we go over the informal one. The first requirement is that all the pivot entries has to be one. So in the last example here, 4 is a pivot. 4 is a pivot. We want that 4 to be 1 when we want to when you convert this when you want to reduce this matrix into row echelon form. So every pivot you have, you want that pivot to be 1.
That example in the previous slide is not in row echelon form.
No. It's just one matrix, augmented matrix. So all the pivot, they're non-one. Non-one. They're not one. So in order to convert your matrix into row echelon form, you want all those diagonal, the pivots are 1. And then you want all the pivots to have a staircase pattern. So from here to here, you're going down stairways. From here to here, you're going stairways. So if you have a pivot and it's 1, you want them to be going in diagonal direction. Or at least you have to go from left side to your right side. So the first pivot has to be your left, the second pivot has to be on your right. You cannot have first pivot on the right and the second pivot on the left. No, you have to have the first one on the left side, and then the next one on the right, and the next one on the right, and the next one on the right. So you have to go like a staircase. You can skip steps in a staircase, but you have to go from left side to right side. And the third condition is that if you have an entire row with zeros, it has to be in the bottom row. If it's not in the bottom row, then it's not in the rational form. The three conditions make one augmented matrix into a row echelon form matrix. Example. The first one is in row echelon form because all the diagonals have the pivots. And there is no problem with anything else. Second one is in rational form because we have all the zero entries in the bottom row, plus when you go from the left to the right, you are going in a staircase direction. See here you skipped a step, but it doesn't matter. As long as you're going from left to the right, then you're fine. Same in the third one. We don't have diagonal here because it's not parametric. But from this pivot to this pivot, you're going from left to right, and the last row is entire zero. So you have all three conditions satisfied. The first pivot is 1. This column doesn't have any pivot because in this row, 1 is already pivot. So one row can have only one pivot. So this row has a pivot, so this column cannot have a pivot because these two numbers have zeros. That means second pivot is here. This one cannot be a pivot because this row already has 1. So this column, we have the second one. So from the first pivot to the second pivot, we want in a staircase direction.
So each row can only have one pivot?
Each row and each column. So if one row has already one pivot, then the second column here cannot have a pivot because it doesn't have anything here. It has a 3 there, but this 3 cannot pivot because one is already pivot. So here, this one is not rational form because look at the diagonals. This is pivot, this is pivot, this is pivot, but are they one? No. We want our pivot to be 1. This one not row echelon form. Why not?
The zeros are on top.
We want zeros to the bottom because zeros are useless. So why do you have your first thing to be useless? You want your last thing to be useless. So you have to put the useless thing on the bottom. It's not the row echelon form. How about C? What's wrong with C? The last one. We have a pivot here, we have a pivot here.
It's inverted. The first gonna be zero.
It's not in left to the right. It's right to the left. We cannot go right to the left. You have to go left pivot and then the right pivot. So pivot has to go in a decreasing order. So it's not in row echelon form. Now, when you have row echelon form, we can actually reduce it more. If you can reduce it more, then you call it reduced row echelon form. And in order to convert your matrix into reduced row echelon form, there are even two more conditions. First, it has to be reduced in row echelon form. Means all three conditions has to be satisfied. Once you have all three conditions satisfied, then you have two more. The leading non-zero entry in each row has to be 1.
I thought that was the condition for the
Previous one. The pivot has to be 1. So some book says, well, in your row echelon form, pivot doesn't have to be 1. As long as you have a pivot, it's fine. This is some book says. But some book says, no, we want definitely our pivot to be 1 in a row echelon. So mathematicians are arguing, okay? So I don't know which one to follow, so I have both of them. Personally, I think it should be 1.
Yeah.
Because if you have 1, you can easily see it's reduced. Whatever. So we can put 2 inside 1 if you want. But the main idea here is, even if you don't have 1 here, you can say, well, it's reduced. I mean, it's row echelon form, but it has to, in order to be reduced, all of them have to be 1. Definitely. And then each leading one is the only non-zero entry. It means besides this pivot, all the numbers in every column has to be 0.
Same column. Same column.
On the same column. So here, we have 1 and this is 0. Even though it's not in row echelon form, but if you put it in row echelon form, it's also in reduced row echelon form. Same thing here, it's not in row echelon, but switch them to the row echelon, it will be reduced row echelon because each row, each column has only 1 non-zero entry. For example, here, this is in row echelon form, but it's not in reduced row echelon form. We can reduce this 1. We cannot reduce it.
We reduce the 3.
We can reduce the 3. We cannot reduce 1. We cannot reduce 3.
How do you reduce it?
If you multiply this by -3 and add with this 3, this 2 becomes 0. So we can reduce. So we can reduce a matrix. It's not in reduced row echelon form. It's in only row echelon form. So one example. We start with augmented matrix.
So when you reduce the 1, you also reduce the 0 at the bottom?
0 at the bottom, we don't care. We ignore them completely. And then we have to see, besides them, can you reduce anything else? If you can, that means it's not in reduced row echelon form. If you cannot, then it is reduced row echelon form. Like these two are reduced row echelon form because you cannot change, you cannot reduce them anymore. This is not reduced row echelon form because we can make this 0 by subtracting. We can make this 0 by subtracting from this. We're going to learn the tricks later, but the main idea here is, if you have a matrix in row echelon form and you see that you can make it even more reduced, then it's not in reduced row echelon form. So the most specific format of the reduced row echelon form is that we have only 1 entry, only 1 number on the each column on the diagonal. So one example is here. We have a 4x3, no, 3x4 matrix, and then we have the last column constant. When you reduce by doing some math, it turns into that. We have pivot, diagonally we have pivot, so it's satisfied. We have no non-zero numbers. All the pivots are going from left to the right. So it's rational form. But we can reduce this even more. When you do more math, it will turn into this matrix. And now this matrix, it cannot reduce anymore. Look at the diagonals. All the diagonals are 1, and each column has 1 below. Each column has either 0 on the top or 0 on the bottom, except the last one. Since the last one doesn't follow that, so this solution actually has the infinite solution. But we're going to talk about it later. Now, let's do this example together, and then you have few examples to do by yourself. A. What do you think about A? Is it reduced or only row echelon? Or it's neither. Not reduced. So not row echelon. Why not?
What the second row, 1, 1, 1, 2, it should be 1, 2, 3. It is.
So it is that reduced. True. But is it in row echelon?
Oh, it is in row echelon. It's not reduced row.
True. It's in row echelon because we have diagonals 1 and they are going leftward from staircase. And the last row of the end is 0. So all 3 conditions satisfied. So it's in row echelon form. Or row echelon F. How about the second one? Not row or reduced row? Not row.
Not row. Not row.
Why not?
The leading
The leading coefficients in that one.
What did they call again?
Pivot.
Yeah.
So not row echelon form. How about the last one? Why not? What's wrong with this?
You can't have the 2 below.
It's not in row echelon because we can make this to 0. Then you can have row echelon.
Does that mean that A isn't reduced?
A?
Yeah.
A is row echelon but not reduced.
Then what's the answer?
It's row echelon form but
No.
not reduced.
The answer to the question.
What is the answer?
Row echelon form. Right?
It's asking which one is.
Oh, sorry. A is reduced row echelon form because we cannot reduce it anymore. Can you? We have 0 here, 0 here. How can you reduce them anymore? This actually reduced row echelon form.
Oh.
In order to make them disappear, you have to have some number above or at least below. If you don't have anything at all, how can you reduce them? How can you get rid of them? Not possible. It's reduced row echelon. And this is not even row echelon. And the last one we agreed what? Not row echelon.
So could you like on the second row you take one off and then make it 0 and then the 2.
You can multiply this by -2 and then add with this one. So -2 plus 2 give you 0. So this becomes 0.
The bottom becomes 0.
We want the bottom to be 0, right? In the row echelon form or reduced row echelon form. So you can easily make this 0.
Okay, so for both raw echelon form and row echelon form and reduced row echelon, it's like the bottom has to be completely 0. Like, they don't have to be, but they can.
It can be 0, it doesn't have to be 0.
So what's the reason that C is not? Because there's raw echelon form. Because
It doesn't follow the staircase. See, if you have a pivot, see every column and every row has to do one pivot. So see here, this column already has this pivot, so this cannot be a pivot. So this row doesn't have any pivot.
So because of that, it's not.
Remember, we can have one pivot in one row, one column. So this column and this row has one. It's pivot, the main entry. This column and this row, this is our pivot, the main entry. If this is the main entry, it cannot be main entry here. So the third row has an entry, but it's not pivot, but it's a leading entry. So it contradicts our pivoting.
I think calling A reduced row echelon, doesn't that contradict what these rows say? That in each pivot column, the pivot entry is the only non-zero entry.
If it's possible, I should have said that. Because not always you can have, only for unique solution, you have diagonal 1 and everything else 0. This doesn't have any solution, you have infinite solution. That's a scenario.
Pretty sure in the textbook it says row echelon form is any non-leading zero number.
Exactly. Some textbook mention you can have any non-zero number. It doesn't have to be 1. Some textbook says no, it has to be 1. So which one I should follow? Use common sense. Both textbook. I took both of them from textbooks. So that's why in the exam I'm going to give you something easier to figure out instead of making this type of things. These are from the textbook, by the way. Okay, so this cannot be pivot, not because it's 2. It cannot be pivot because of the column and row wise. Column wise, this is pivot, right?
The one, yeah.
That means this cannot be pivot.
Right.
But row wise, it has to be pivot because this is our first non-entry number. So does it make sense? Column says you cannot have it there. Row says it has to be there. Contradiction. Any other question? Okay, then you have 6 of them. Figure them out. And it's our prayer time, so let me take 5 minutes to pray, and then we'll do them together.
We're doing A on the left, or A on the right. A on the right.
On the right page. Everything on the right page. Talk with your neighbors. Exchange your ideas.
Or like the A, so the pivot is one, so that's good. You can also give them the row. Because the second thing is 0, because they're not pivot or.
Yeah, so.
Right page.
The right side. All 6.
Remember, the pivot has to be.
And I'm not sure about that. D is definitely no. But I'm not sure.
Like the next column also.
Oh, yeah.
That's where.
Yeah, so those should be from the left.
For B, the 0 row has to be at the bottom. For B, See, I mean, that one.
It can be.
I think that one.
Yeah, so as long as it's
All
and then E would be not reduced. Yeah, E is just regular.
I know B is.
Well, yeah, well,
Even though
the
it's in the
definition, that's allowed.
just because of the
So I the first one regular, it's in the textbook, it says.
Third one.
Technically, yeah.
Textbook said that.
It just has to be a non-zero number. Positive, negative. But in reduced, it always has to be a positive. So I guess that's the biggest difference. In row echelon, you can have negative numbers.
This. Yeah. It has to be all in the exact same thing here. Just have 130 or 1. And here, those numbers. But she's talking about teams. Yeah, it's like so they don't really care about because they think because you cannot regulate city whatsoever because you don't have anything. So if you can't,
Elementary raw operation. I don't remember. We'll learn about it.
Yeah, wait. So you don't have to do the column in the column in the same row. They're 21 that you can use. So once you have this, then you
not
I heard them.
I think so because
But
so that's all
it can only put.
so you
But it cannot
use column
reduce has to be all three.
so the one
And then the above and bottom.
It doesn't
It can be the hundred.
right
and then you go down.
sounds
So it's like
No, I'm saying, it's not that I'm cycling for rational anymore. It's that right now, it's not.
right and
I think the three has come here.
It's either right now, technically. Because by her definition,
Yeah.
yeah
yeah, but like, there's like different definitions. That's the problem. But like, like, the one thing mathematicians will agree on is that reduce row.
Yeah, that's exactly. So if you're
It's all
yeah but those are
leading non-zero numbers are always one, and it's the only number in the column.
There's no number in the bottom, but there could be a number or
It could be, no, it has, so in the column, in the reduced row, it can't share anything. So like, look at C, right? See, in the second row, the first leading non-zero number is one, and it's by itself. And then look at row one, row one is also the first leading non-zero number is one, and it's by alone by itself. That in that column.
but yeah
So like, vertically, you have to worry, but like, you can't have that three.
the third one
So what if it was like, what if
on the second one
I think
that'd be on the fourth one
or yeah,
and I guess
and
on three and five
one and
but
we
we
don't
don't
have
have
or like you see the
I think you were talking about
That would be really
you can't have
reduce, it has to be the
the child work. It's not our third row. Like, the second one is the second one.
So it has to be a random one. So like I said, no, D is C, like reduce the other numbers are.
Like, it's still there. That like it's like so when all the zeros go up. Oh, you can't reduce it. You can't reduce it. Right. Fine. Reduce. G is.
So what is, you have to do that to like reduce the
There is some like.
Yeah.
For the, or no, that's right.
Like the nine. So like if like imagine there's no.
Yeah, that's right. Then
There's just one there.
because I
so you don't go to boundary, you go that.
I just got
It goes through.
Yeah. Cause like, it's like if you have a zero row, it's like inconsequential, cause it doesn't mean it. The zero is always equal to zero.
Yeah, I got it. Like, see? Like, now,
like not.
or, yeah,
Not around.
because they have to like.
Let's
Is it?
set.
No,
Yeah.
is it? There's no.
oh It's first of all, well, for the F1, I think it is not, because here you have a staircase that goes like this. And in the one, there's another one, and then there's a number under the one, always by itself. I think you're like.
Saying that, bro.
Only one.
I know it's a show now. What they do.
Yeah.
I'm gonna do that when they come. I'll do it.
Let's use the blue brush, look. Yes.
Ready? Okay, so what do you think about A? Only row echelon. Okay. Any complaint? Any objection? So all you agree?
So how would that be reduced? Row echelon? No, but how would
Get
it,
rid of 3, you can get rid of 4.
so could you like show it?
Later. So anytime you have numbers top and bottom, you can reduce them. For example, here 2 cannot be reduced because there is no number here. But 3 and 4 can be reduced because there is a number below them. So how are you going to reduce? That's the thing we are going to learn. So what? What did you say?
Like, could you make the 3 on 2 and the
We can make 3 to be 0, and we can also make 4 to be 0. For example, you can multiply this by -3 and add with this row, then 3 will become 0.
oh,
-3 plus 3 is 0, becomes 0. And they get non-effective because these are 0. Same thing, you can multiply this by -2, and if you add, then this 0 will turn into a non-zero number. So you can reduce one of them, probably not both of them.
Yeah, there's one.
As long as you don't change whatever you already changed and you needed that, you cannot reduce the other one. We're going to learn all those tricks later. Just for now, know that if you have a number top and bottom, then they're reducible if you have all the non-zero, all the 0 number on the left. Okay, so the first one is reduced, not reduced, only row echelon form. How about the second one? Why not? We have a problem, the 0 in the middle, so it's not row echelon form. C,
yeah.
reduced row echelon form. Any objection? Any question from anyone? You know, so on the bottoms, one condition satisfied, and from this one to go to the next one, you want a staircase. You skipped a step, but it doesn't matter. It's from left to right. The second condition satisfied, and then third one, the bottom one.
And then the
And
3,
you cannot reduce 3 because there is no number here to reduce it.
all other integers are not
Zero.
0.
Mm-hmm. So see, each column has only one non-zero entry. This one, one. This column has only one. This column has one. So every column, they have only one non-zero entry. So it cannot be reduced anymore. Okay, D. Reduced row echelon form. Any question from anyone? Why?
So, did it start at one, and then it starts with diagonal from there? Okay. But let's say like where on the second row, if the one was there, then it would not be,
Reduced
yeah, because it's
to
going.
only row echelon. So even doing the zero here, but everything else is only one pivot, it doesn't bother us. E, what do you think about E? Why not? What's wrong with that? So we want T to be one, so it's not row echelon form. But some book can argue saying that, well, it can row echelon form because our diagonals have non-entry numbers. So according to some book, it's in reduced form, in row echelon form, and some book says no. So in that, I'm not going to give confusing one.
Okay, so for the sake of this class, it's gonna be.
I'm going to give one.
Okay.
So I'll ignore the problem. F.
That is that.
Not why not? What's wrong with this? No staircase. See, from here you went right and then you went left. You cannot go right, left, right, left. You have to go from left to the right diagonally. So the diagonal doesn't follow here. It's not in the echelon form. Not the echelon form. Any objection about any of these?
With the big circle, the middle, section, is it because for the pivot table, every row has to value?
No.
Because
In order to be at least rational form, if you have entire row to be zero, it has to be at the bottom. So if you put that here, then it's in rational form. It has to be on the bottom here. Same thing. Which one? This one has to be here, and this line has to be there. So to go diagonal.
You can you like.
Swap them. If you swap them, then it's in row echelon form. But right now, without doing anything, it's not anything. So let's see. ACD in row echelon form, and from ACD, the CD is reduced echelon form. So you guys are correct. Good job. You did excellent. So you're ready for the next one. Next, we are going back to yesterday's class, last class. Do you remember when I said there are two types of solution here? Consistent, inconsistent?
Yeah.
So two types, consistent, inconsistent.
Inconsistent is not solvable.
No solution. And consistent meaning you have a solution. But for consistent, how many types of solution you have? There are two scenarios. Either you have unique solution, like for each variable they have their individual solution, or infinite solution. So for consistent, there are two choices. Either unique solution means each variable has their each number, individual number, or infinite solution means all the lines, they're the same line. So point is inconsistent, no solution. How can you figure them out? By observing all the zero rows. If we have all the coefficient to be zero, but suddenly the constant to be non-zero, it means you're saying, hey, all the coefficients No. There is no variable has a solution. So no variable has a solution. Does it make sense? No variable has a solution. It doesn't make sense. So it's not solvable. It's inconsistent system. And consistent system has this setup. You have diagonals, ones, and then below the diagonals, you have all the zeros. Above what you have, you don't care, but below, they have to be zero. Now we are going to find the solution. So for each case, we are going to find whether they have a solution or they don't. They do have a solution. What type of solution they have? Unique or infinite? Easy one, A. Does it have a solution? Why not?
The last row is the code.
No variable has a solution.
Mhm.
Doesn't make sense. So because of the bottom row, it's no solution. No solution. Any objection? Inconsistent system. B,
Consistent.
consistent has a solution.
Unique.
So when you have a solution, you have to find them. So how are you going to find the solution? Good job. So you start from here. What information you have here? So we have two variables, x1 and x2. The second row is telling us that, hey, your x2 is -1. So we already have one solution for one variable. And now we go to the first row. Let me change the color. What information we gain from the first row?
1 plus 3 times 1.
Say it again.
1 plus 3 times -1. That's how you write. You substitute.
You write x1
Okay.
plus 3x2
Yeah.
equals 1.
Right.
So this is the equation, and now from the equation, you're going to solve. So from x1 and x2, do we know at least one of them? How much is that?
Yeah.
Which one we know?
X2.
So you're going to substitute that. So we have x1 plus 3 times -1 is 1. So x1 minus 3 is 1. So what is x1?
4.
4. So what type of solution it has? Unique or infinite? Unique. So when you have unique solution, you write all the solution out. Solution x1 is 4, x2 is -1.
We write them as a set.
I prefer this, so I can see which one is what. If you try to write a set, then people make mistake by putting wrong numbers in wrong place. Any questions so far?
I do subscribe. I did one.
X2.
X2 is -1. We get the information from the second row.
Oh,
So the first row says x1 plus 3x2 is 1, but you already know x2 is -1. So this is called back substitution. You start from the bottom and then you go up. Now the third one, C. What type of solution it has? I mean, does it have a solution or no? It doesn't. Which one? It does.
Mm-hmm.
So what type of solution we have? Start from here. What information we get from the second row? Good job, x3. So they tell us that x3 is 3. And then we go to the first row.
We have two variables now in the first row. We don't.
So x1 and then
X2.
minus 2x2
plus 4x3
4x3
equals 1.
equals 1. Which one we already know?
3.
X3. So x1 minus 2x2 plus 4 times 3, 1. So we subtract 12. We get x1 minus 2x2 is
-13.
negative 11. And then what is x1? You add this amount, right?
Oh, yeah, plus 2.
You add 2x2. So x1 is 2x2 minus 11.
I don't have to.
Yeah, but we have a problem, right?
The X.
We don't know what is x2.
It's a
So we write one more line. Well, x2 is itself. X2 is x2. It could be anything. It could be 1, 2, 3, 4, 5 million, billion, whatever. X2 could be anything. X1 is twice x2 minus 11. So x1 depends on x2, but x2 could be anything. So what type of solution we have?
infinite.
Unique or infinite? Infinite. So we have infinite solution. But when you have infinite solution, you have to write down the solution for each variable. For example, here, our x3 is fixed, and these are not fixed. So what some book does is they assign a variable for the free one. So here we have a free variable x2. So if you want, you can say, well, x2 is theta, okay, x2 is theta, then x1 is 2 theta minus 11, which I dislike. I want to see my variable. So I prefer writing this. X2 is x2. Start with the free variable. Whatever is free, start with that.
Find out is important.
I am not sure yet.
If it is, I'm pretty sure they want data.
They want
But
alpha.
I'm going to grade. So x1 is 2x2 minus 11, and x3 is fixed 3. So for infinite solution, I want two things. First, write down we have infinite solution, and then the variable or the equation for each variable. Go ahead.
Is that X2?
Is it x3? Are you thinking about this one?
Yeah, I just want to back. You got negative 1 is X2, and
Because of the second row.
and that's from the second row.
Mhm.
And then X3.
This is my x3.
No,
This is
from the
x1 and this is x2.
C.
Oh, okay.
And then X3 is 3.
X3 is 3. It's fixed.
So this one is
It's up the third column. You know, the column.
So x1, x2, x3. If you get confused, what I do is write down each variable. X1, x2, x3. Based on how many columns you have, write down those many x's, and then you can see clearly what is given. You cannot just name the last column. So we have only 2 variables here. So x2 is -1. But here we have 3 variables. That means x3 is 3 now. And x3 has a coefficient 1. So 1 x3 equals 3.
That's what I was.
These are the coefficients.
It's the one you're looking for, and then you match it to the number.
Variable.
I got it.
No problem. Any other question?
So we put the arrow echelon form so that we can do back substitution.
If you use echelon, then you have to use back substitution. That's why we want to get reduced echelon. So they don't have to use back substitution. But when you have infinite solution, we actually have to use back substitution anyway to get the solution because we have infinite solution. For example, here, this is actually reduced, no, it's not. So even if you do a reduced echelon form, you still have to do back substitution because we have two variables at the end.
Okay, so, when you think triangular form, that's in the.
Row echelon form. Row echelon form. And then in this triangular form, if you have zero, all the entries zero below the diagonal, and all the entries zero above the diagonal, that means you have a unique solution. So you don't have to do exact substitution. Each variable has one solution. I think we are going to have that. Probably not. We are going to do that example later. When you have unique solution, you'll love them. Like, oh, our diagonals, only diagonals have one, everything else is zero. We know the solution right away. So you don't need back substitution unless it's infinite solution. For unique solution, you don't need back substitution. If you have reduced the echelon form. Okay, quickly. Do you want me to go over them? These questions? I did it with my the class before, so just watch the recording. It's the same scenario, okay? Blah, 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 blah. And also I have the solution. So if you do them by yourself, you can check your answers. Now, to get the echelon form or reduced echelon form, the math we are going to do, we have the name for the process. We have two names. One is Gauss elimination and one is Gauss-Jordan elimination. So if you convert your augmented matrix into row echelon form, the process of converting that is called Gaussian elimination. And if you do reduced echelon form, whatever process you do, that process is called Gauss-Jordan elimination. So two people worked here to get that reduced row echelon form, and only one person did the math for the echelon form. These are just names. So how these two methods are different from one another? Easy. Even though they both have similar methods of solving them, but the difference is that Gauss elimination method gives us the Gauss elimination method. In the Gauss elimination method, the matrix is reduced into upper triangular matrix. It means all the diagonals are 1, 1, 1, 1. And then you have numbers, 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 numbers. You have numbers everywhere and zero on the bottom. So this is Gauss elimination. Once you have augmented matrix and you do row reduction and you get something like this, diagonals are 1, below diagonal you have 0, and you have anything here is Gauss elimination. And then for Gauss-Jordan, it has to be a diagonal matrix. Means 1, 1, 1, 1. Everything else are 0. If it has a unique solution. For a unique solution. If it doesn't have a unique solution, then you're going to have some numbers here. Like the example we did before. Like that. Yeah. But in general, if a system has a unique solution, Gauss-Jordan means 0, 0, only diagonals are 1. And now, a heads up about how we are going to do row reduction. What are the steps we can take? So do you remember what are the 3 allowed steps to reduce a matrix? We talked about in our last class.
Swap row.
1, swap row. So you can swap any 2 rows. What's the second one? The second thing you're allowed to do in a matrix? Add 2 rows. Add or subtract.
And then
By
coefficients.
a non-zero number.
Yeah.
So you can multiply
Integer.
by a non-zero number
Okay,
It cannot be 0.
you're not taking division?
They said multiplication is the reverse of the reciprocal of the division. So instead of they said dividing by 3, we say multiply by 1/3. But they're the same thing.
For us to track.
But I'm allowed to divide,
You're allowed to divide by a number.
but like in your class, I'm saying, I'm allowed to divide.
Divide by a number.
Yeah, of course, it's a number. Divide by. But I'm saying, am I allowed to?
You
divide?
can multiply and divide by a number, a non-zero number.
Okay,
You can add 2 rows, or you can multiply 1 row by a number and then add with the second row. So multiplying addition or subtraction is allowed. Multiplying or dividing by a number is allowed. Adding or subtracting 2 rows are allowed, and swapping any 2 rows are allowed. These are the 3 allowed operations to reduce our matrices. So now we have a nice matrix given to us, but it did not mention whether it is a coefficient matrix or an augmented matrix. So how do you know?
it doesn't have a line, so it's coefficient.
It should be, right? But what's the point of reducing a coefficient matrix? What do you get?
Diagonal.
We get back nothing, like we don't get anything meaningful. If you want to reduce a coefficient matrix, we don't get any meaningful information. Since they want us to reduce this, so you have to assume it cannot be a coefficient, it has to be augmented matrix. Mathematically, reducing a coefficient matrix doesn't give us anything. It just reduces the coefficients. But what do you do with these coefficients? What is our goal? Our goal is solving, right? So without the constant column, how can you solve anything? So we have an invisible line here, which you can make visible if you want. So how many variables we have? 4 variables because we have 4 columns. So that means we want to get 4 solutions. And our goal is to get all the diagonals 1, everything 0, everything 0, if possible. If not, we want at least the bottom to be 0 of the diagonal. So we want to convert this into 1 something 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 0 something something, sorry, 0 1 something 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 0 0 1 something something, and then 0 0 0 1 something. This is our goal. During this process, if we can make all of these 0, that's a plus. So first convert this into row echelon form. So we want this to be 1, but here is 0. How can you solve this problem? We can solve this easily. So row 2 stays row 2, but row 2 becomes row 1 becomes row 2. So switch row 1 and row 2. The first problem is solved. Here are the steps. Switching them, we have 1 0. We have 1 0, we're happy. At least one thing we got what we wanted. The next column is 2 here. These 2, what do we want? To become 0. So what can you do so that this 2 becomes 0?
2 times row 1.
You can multiply row 1 by -2.
And then add it.
Add with the row 3.
Yeah.
That will be a new row 3. So we're not changing row 1 because we are happy with row 1. We're not changing row 2 because we are happy with row 2. But we have to change row 3. We are going to get the help from row 1.
Row 3 minus
So
2 row 1.
row 3 minus 2 row 1 is our new row 3. So anytime you do any operation, you have to indicate that on the side or down there somewhere. But you have to write down your operations. So once you do that, this 2 will turn into 0. So we are happy. We have 1 0 0. We don't care about anything else. We are doing column wise. When you reduce your matrix, you should go column wise. Am I confusing you guys?
No,
Little bit?
So everything like when you swapped, you only swapped you swapped the whole column.
All rows.
Yeah, the whole row. Yeah. You swap the whole row. You swap. And then when you do like any sort of math, you only do it in the column.
Whatever you want. No, when you do it, you have to do row wise. Everything is row wise. You can never do anything column wise. Okay, let's do the math here. So you understood swapping, right? And now your goal is to make these two into 0. So we're saying that, well, subtract 2 times row 1 from row 2. Let's do the math. Hey, wait. I didn't take that attendance. So, what's your name?
Waldo, Ethan Waldo.
Ethan, start with E.
Yeah, Waldo, W-A-L-D-O. Ethan Waldo, E-T-H-A-N.
Oh, yeah,
Thank
okay. Let me also take attendance for everyone else. Kenyon? Alisa?
Yeah.
Emmanuel? Jose? Or say Josh or Jose? Jose, okay. Arjun is here. Gregory?
Sure.
Bora is here. Tenzin? Tenzin Chandan? Christian? Andy? Park? Jackson? Abid? Vlad? Yeah, Vlad, right? Mehrab? Chuan? Chuyan? Sorry. Anybody's name I did not call? All right. Okay, so let's do the math to make your life easier. One page. So our operation is new row 3, which usually we indicate by a star. New row 3 is old row 3 minus 2 times row 1. This is the operation. New row 3 is old row 3 minus 2 times row 1. So our row 3, let's write this down. We have 2, 4, 1, negative 3, negative 2. Now, if you multiply 2 with the row 1, we get negative 2, or do you want to multiply with positive 2? Whatever. So negative 2, negative 4, positive 2, 0, negative 4. Right? If you multiply 2 times row 1, so negative 2 times row 1, you get negative 2, negative 4, positive 2, 0, negative 4. And then you just combine them. You get 0, 0, 1 and 2 gives us 3, negative 3, negative 6. This is your new row 3. So you keep your row 1, you keep your row 2. You don't have to change them because you like them. But the row 3, old one, turns into new one. 0, 0, 3, negative 3, negative 6. And you keep your fourth row because they're allowed to do change in only one row. No, sometimes we do 2 rows. So here we want to change only the third row, so we keep our fourth row same. And now we don't like 1, so we want to change this one into what? 0.
Other changes also affect the coefficient.
The entire row. We don't go column wise, we go row wise. Column wise, we want only 1 on the first one, and then everything else 0. So we have 1, the first one, and 2 zeros, but this is not 0. So our next goal is to convert 1 into 0. So we go get the help of the first row. We can do the new row 4. So let's do it here. Our new row 4 is old row 4 minus row 1. So this row 4 has 1 here. If you subtract this one here, it will turn into 0. So we have row 4, 1, -4, -7, -1, -19. Row 1 is 1, 2, -1, 0, 2. If you subtract them, so minus, minus, plus, minus, minus, you get 0, -6, -6, -1, -21. Wait, did I make a mistake? No, it's correct. So this is our new row 4. So you keep your row 1, keep your row 2, keep your row 3, but the last row is not the old one, it becomes the new one. That's how we do row reduction. We go column wise, one by one, but when you go column wise, we change the entire row for every row. Confusing, is it? We're going to lots of examples, so don't worry. Today is just the beginning. The idea here is that you keep going like this one by one until you get what you want. So if you have diagonals all the ones and below the diagonal 0, you can stop if you want because you already have your row echelon form. This is in row echelon form. Yes, you can reduce it, but you can stop if you want. If you stop here, that means you have to do back substitution. You do back substitution based on whatever information is given. The last column is solution. So they're telling us x4 equals 3, x3 minus x4 is -2, x2 plus x3 minus x4 minus twice x4 is -3. So you have to write this way and you get all the equations and then you substitute one by one and get the solution. So homework, next Monday we don't have class, but your homework only Monday for us. I have a conference to go to. So your homework for 1.2 is 2 to F, 3A, 4 to F, 4 only BT, and here are the partition question if you want to do them. Ignore 6 and 8, we are going to do that after we learn how to do that.
Like, I'll take a picture of the questions again. Okay.
Not 6, because we are not 6 yet. But if you want, you can submit. So, have a good night. Have a good 1 week. See you again after 1 week.
Yeah. Like we're learning this completely hardware, so what is like the actual use of like matrix stuff?
Are you doing engineering?
Or on computer science?
Computer science use matrix systems all the time.
Yeah, but
so when you go actual computer science field, you're going to do all of them. Bye, have a good night. You have to do all of them. So you're not going to do them manually, but if you do coding, you have to tell the computer, tell the system that do coding using this math. So you have to learn how to give the direction to your Python or whatever you have for the system, and then they will do everything for you. But how you're going to instruct your coding system, you have to learn that. So you're learning the math here, but you're going to apply this math into coding in computer science. And also there are other fields.
okay, but it's like sort of like the process of
like you're going
like
to
feeding
do something in
information to
computer science, right? And most of the computer science is coding, if I'm not wrong.
yeah.
But if you want to do coding, you have to know how to tell them to code it for you. Like do the math. You're not going to do the math. You have to know the math to direct your machine to do the math for you. So you're learning how to do the math. X1 is 5 x2 minus 11. And we know x3 is 3. Then what is x2? X2 could be anything.
Also, you would just put it as x2.
So x2, because x2 it means x2 is itself. It could be anything. Whatever we feed it, it will become that. So you cannot place a number for x2.
But if x2 be in the solution, that's what you would just put it as anything.
So you don't write as anything. You write x2 is free.
So you would just make it equal to itself. Okay.
So it's a free variable here.
Okay.
But you cannot just write x2 is free. Like it's not wrong, but it's unprofessional. So in professional way, we express that x2 is free, saying that well, x2 is itself. It's just itself.
Okay. Thank you.
But in many books, they actually assign a variable like t or s or p or q. But this basically means it could be anything. Have a good night.